Parts of a volcano. So all the volcanoes are going to have really characteristic features. That magma chamber, my dog is here with us. That's why I have changed clothes to walk my dogs. They know it. The magma chamber there, that big glowing blob, that is going to build up with magma, and then if pressure increases enough, the volcano erupts. Down here at the bottom, just see sinking, they've snuck it in here, is an intrusion. So some of that magma is going to cool and crystallize into a intrusive igneous rock. But if it doesn't, it's going to come out of the volcano. So coming out of the volcano would be at the vent here at the top. Fissure eruptions are going to happen on the flanks of the volcano. So see here on the sides, little cracks. And we'll see another slide in a minute where a fissure can be like a long curtain of eruptions. The craters at the top of the volcano. Here's some of the products we've already discussed. The ash, small bits, lapilli, like little pebbles, and then bombs are going to be like the size of your head. They're usually going to be that lens or football shaped because they're going to come out of the volcano as magma, and then as they fly through the air and solidify, they take on that football shape. The magma chambers are in the upper crust. So this is just zooming in on that magma chamber. They're up in the crust, and they are going to, well, I already said, like you can get these intrusive rocks kind of growing on the outsides of the magma chamber. The magma is going to be under pressure. It's just going to rise up to the surface and form that volcano. Here are the fissures. So these are real things. They can be big lines of eruptions. So here's a fissure eruption where here's a crack. This is at Kilauea. And then a line of eruptions across the land surface. So they're called curtains of fire. And they're not going to have like a crater or a little vent. Eventually, maybe they'll coalesce and form that over time. So, yep, at the top of the volcano is the crater. They have a little depression at the top where the vent is. Craters can be really big, 500 meters across. That's pretty big. They can be really deep. It's like down into the volcano, like a crater shape, 200 meters deep. The lava is going to come out, and if it's like a rhyolitic lava, it could just form that lava dome right at the vent. Otherwise, it's just going to kind of blow the crater to bits every time it erupts. There can be eruptions that just emanate from the crater in that vent. That's a summit eruption. These are the flank eruptions here on the side. But either way, they both come from the magma chamber at the bottom. If the magma chamber empties completely, then the volcano, thanks Bodhi, is going to, if the volcano, bye Bodhi, if the magma chamber empties during eruption, then there's going to be a void space. And then the volcano can collapse in on itself. So that is a caldera eruption. So these images are kind of backwards. That was confusing me. But over here on the right, there's the magma chamber and all the materials coming out, boop, 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 erupting. It empties. And then on the left here, now, because that void space was there, the volcano kind of implodes on itself. Crater Lake in Oregon is an example of that. So if you go into the static lecture, just the PowerPoint presentation, click on this link here and look at, it's kind of a tour of Crater Lake in Oregon, one of the deepest lakes in the world, really beautiful. So that is a old caldera. They're at the top of the old volcano. Yellowstone National Park is also a caldera. So it has two little resurgent domes. So after the volcano erupts, then later you'll have the magma chamber refill and make a little dome inside the volcano. So that's what you'll see at Crater Lake and also at Yellowstone National Park. When that viscous basaltic lava flows, it can flow really long ways. So it comes out the vent, it flows laterally, and makes these huge shield volcanoes, broad, slightly dome-shaped, and it's called shield because it's like an inverted shield, like if you laid a shield down on the ground. Low viscosity, basaltic lava, flows a long ways. They can get very, very big because they grow over time. So each of these lines here is another lava flow. They get bigger and bigger and bigger as time progresses. This little link here is a link to see kind of the formation of Mauna Loa. So go back to the regular PowerPoint and click on that and look at the video of Mauna Loa. A much tinier volcano is a cinder cone, and these are really just piles of tephra, so pyroclastic material that's come out of the crater. So this is a cinder cone. They're really beautiful volcano shaped, right? So perfect sides, and then the crater at the top. They're little. They form from a quick eruption of gases. So this material, this is basaltic, so it's chunks of basaltic lava that just forms the whole sides of the volcano. Because there's lots of friction between those angular chunks, the sides can be pretty steep. This one is SP Crater, and there's a video here that you can see SP Crater. All of this is makes up the main volcano is from that tephra eruption, and coming out of the top of it up here is a later basaltic flow after all of the gases have escaped. Stratovolcanoes are the big ones, like here is, I can't find a place for my face. Here is Mount Fuji in Japan, and that forms the subduction dome there that forms the volcanic island arc that is Japan. But also our stratovolcanoes are the Cascadian volcanoes like Mount Rainier, and then also Vesuvius is a stratovolcano. Strato, that part, means like layers. So this upper image here shows layers after layers, and the layers are layers of pyroclastic material and layers of like lava coming out. So they alternate, and then they are able to stack over time and form that big stratovolcano shape. They're also called composite volcanoes. You can use either term. Yep, alternating layers of tephra and lava and debris. Okay. So we looked at the different kinds of volcanoes. Now let's compare them, because there are different shapes and different sizes. So a shield volcano is the largest one. You take a shield, you lay it on its side, it's going to form this broad dome that's shield shaped. So this first one is a ginormous Hawaiian shield volcano. And then look at how much smaller these stratovolcanoes are. So really way smaller than the big shield volcanoes. A much smaller one then are those cinder cone volcanoes, right? So we looked at SP Crater is a tiny little one in the image that I showed, and then the video is also SP Crater. That is kind of like private BLM. I don't know if it's private or BLM land, but you can just go there. Sunset Crater, the one in this figure, is a like a national monument, kind of like a national park that you can go visit and learn about. Cinder cones in Arizona. It's kind of south of south of the Grand Canyon, north of Flagstaff. And here is a like kind of similar on the similar scale as a shield volcano is this caldera. So this is the Yellowstone caldera. You know, maybe it was a volcano of some size, and then it blew the top off and collapsed. And so you have the large caldera here as the Yellowstone caldera.